If you're a maker of electronic devices, you know this problem. Your home is cluttered with an endless collection of electronic components, microcontrollers, resistors, and so on. What if there was a device that you could use for prototyping anytime without sourcing all those parts needed first, which often takes weeks and has become more complicated in recent months because of the situation.
For this video I was given a prototype of the Cosmolab for free, so everything you see here might be subject to change or improvement.
Hi, you're watching Floyd Steinberg's YouTube channel. And today, the Cosmolab by faselunare. This is a rapid prototyping board for your audio inventions with the Electrosmith daisy at its heart. If you're interested what this can do, please join me in the following minutes. Here we go.
The Cosmolab is a collection of high-quality audio and synthesizer components gathered on a board, everything you need to prototype your own audio hardware devices like effects pedals, synthesizers, compressors, sequencers, modular gear, whatever you can think of. At its heart, there's the Electrosmith daisy MPU, which already is at the center of many successful commercial products like the High Chord, the Replay Analog Synth, or the Hothouse pedal I showed on this channel quite a lot. On the wooden board of the Cosmolab, we find 5-pin MIDI in and out ports, a headphone jack, stereo 6.35mm audio inputs and outputs, the main board containing 2 switches and a headphone volume control, an SD card slot, 8 controlled voltage or CV plugs, an OLED screen, 8 potentiometers, one board with 16 light-up keys and another board with 16 light-up keys that are arranged in the shape of an octave keyboard. In order to use all the components on this board, you'll also need a 9V power supply which can be plugged in on the left side. So, how can we use this? Luckily, faselunare provides an easy-to-use library of examples on a web page that also can push the example code onto the daisy MPU quickly. If you are on Windows, before using that page, you need to download a tool named Zadig that installs USB drivers compatible with the daisy's firmware flash mode. On the daisy, press and hold the boot button, then shortly press the reset button and then release both buttons. Connect the daisy to a computer with the USB cable. Then start the Zadig tool, check Show all devices and select the FS in the View mode entry from the list. Then hit the Install button and wait. Once the installation is through, you can then try all the examples from Cosmolab's webpage. Every time you want to load a new example, hit the boot and reset button on the daisy again and reconnect the webpage and then transfer the firmware. Here are some examples. Developing your own audio applications is quite easy. Cosmolab provides all the libraries needed on their GitHub page. Here I download them to my Raspberry Pi. Simply install all the dependencies and then run the setup script. The examples are written in Python and C++, and they are all well documented. If you don't like written languages, you can also use plugdata, a standalone extension of PureData, for developing audio applications.
Plugdata is based on PureData, an open source software that lets you create complex audio applications like on a modular synthesizer. There are pre-made components, but there's also logic and code you can add, and then all connected with cables. Plugdata comes with the heavy compiler, which turns your audio application into a firmware that you can upload to the daisy seed.
To use the Cosmolab's controls, we can take a look at the JSON file that comes with the development files. Here we can look up the names and pin numbers of the controls. Let's create a simple reverb effect in which we can control the length of the reverberation and its brightness. For this, let's add 4 delay lines to our canvas. I'll use a buffer size of 1000 milliseconds here just in case. Add a variable delay read here. On this, we can modulate delay time, resulting in a slight change of pitch. Let's add a very slow oscillator to each delay line and multiply and shift its output ever so slightly, using different numbers on each delay line. And then we'll add a low-pass filter to each delay read and an attenuator, both to dampen the delay repeats slightly with each iteration. In order to turn this into an actual reverb effect, we could add a line of all-pass filters to this to slightly smear the sound, but that's beyond the scope of this video. My goal for today is to add a control for the filter brightness and delay attenuation. In Cosmolab's library folder, you'll find a representation of the board and how to read the hardware inputs. For example, I want to use 2 of the encoders here and use that value to set up attenuation and filtering. So let's read that, multiply the value and feed it into the amps and filter cutoff frequencies. After this is done, open the Compile menu in plugdata, select Custom JSON, then select the Cosmolab's JSON file, then hit the Compile button and wait. Your firmware is compiled and transferred to the Cosmolab, which should then reboot and run the code.
Well, that wasn't too shabby for roughly half an hour of work on my behalf.
Verdict: Cosmolab is a great prototyping board that provides all the components you need for audio hardware projects, allowing you to focus on software development. You can then later source the hardware you really want to use to create an actual product. It takes away the clutter and the need to continuously buy yet another screen or another set of buttons, and most importantly, it invites you to try new things rapidly.
Yeah, and that's it for today. The Cosmolab prototyping board by faselunare. So if you think this was a good YouTube video, please do the YouTube thing. Seeing those subscriber numbers grow makes me happy and keeps me motivated to push out a new video every week or so. You can also support me on Patreon or by becoming a channel member using the join button under this video. But of course, none of that is mandatory. As always, thanks for watching and see you again next week. Bye bye.